over to this computer. And here we go. I'm going to open up the slideshow on my end. Please make sure that you get into that on your end and be ready to go. Once you are in, I want you looking at slide number 5. That's the first slide for you guys. And I want you to look at those 4 graphs and decide which one does not belong. And then tell me why. Oh my goodness, Mr. May. Not on the first time though.
Hey, Mr. Main, I have a question. If we finished at least 20 minutes of Alex and CCR, do we still have to do it for homework?
So that is the thing, is that by the end of the week, you have to have 60 minutes done. So I gave an extra 20 minutes for homework today just because we aren't, I don't know, like some people don't do it during CCR. So if you're going to be on track to finish it by the 60 minutes by tomorrow, then no. And I'll still mark you as having it. But make sure that you're going to have your 90 minutes done. Does that make sense?
Okay.
Or your 60 minutes?
Yeah, so can I turn it in?
How many minutes do you have in there right now, Sawyer?
I have like 40 left.
I would do 20 tonight though, because you have to get 40 done by tomorrow at midnight.
Okay.
So the reason I'm giving you homework is so that when you get to the end of the week, you don't have to do any to make it up. So usually I'm not going to give you Alex homework time, but this week we just didn't have as much CCR time, so I gave it as that as well. So you can turn it in. I mean, if you want to do 40 minutes tomorrow, then you can do that. You just got to have the 60 done by the end of the week. Thank you for reaching out about that, Sawyer. That was a good question. Okay, taking one more minute to decide which one of these graphs does not belong and tell me why. One more minute. Let's do it. Let me know in the chat. Give me a letter. Which one does not belong? Nice job. Jaden Ramos gave me his answer. I love it. Oh. Nice job, Sawyer. Nice job, Avery. Nice job, Jaden Ramos. I figured you didn't mean to put that. Nice job, Olivia. Perfect. Nice job, Courtney. Oh, I like that one, Courtney. Okay, here. Ready. And go. 3 more seconds. Oh, let me turn my camera. Okay. Here we go. Who would like to share? Which one do you think does not belong? What do you think, Bridget?
I think A because it was the only graph that didn't have lines that intersect.
A because you're the only one that won't intersect. Good. Okay, let's see. Courtney said B because there's no yellow line. Good. Okay, and Gabby said it's because it's the only one without 3 lines. Good, nice job, Gabby. Same sort of idea. Same choice, different idea. Good. What else are we thinking? Did anybody say anything other than A or B? So I mean, you could say I could say C, because it's the only one that has a 90-degree angle. This is close to a 90-degree angle, but it's not a 90-degree angle. Boom. You could say this one, and you could say because it creates a triangle. I like it. You could say this one because all 3 of them meet at one spot. Right? Because if you look at this one, they don't all meet at one spot. I didn't even see that last period. Lots of good ideas here, my friends. Awesome, awesome, awesome. Let's make sure if we didn't get this down, we get one of these choices down, and we're putting an explanation why. Sawyer said something they all have in common is that how none of them go through the origin. I love it, Sawyer. So it's not a what type of relationship? Proportional relationship. Yes, Kaylee B. I honestly, I didn't expect anybody to remember that. That was amazing. There are no proportional relationships. Boom. I love it. Nice job, Kaylee B. I'm really impressed. That was very impressive. That was a really cool thing to notice there, Sawyer, as well. I didn't even notice that. Nice job. Okay, so today we are talking about this concept. Well, actually, let's go through our learning targets for today first. So our learning goals for today, okay? Let me move this guy. Number 1, I can identify ordered pairs that are solutions to an equation. We've talked about this idea of when we talked about equations, we talked about solutions to a single equation. But today, oh my goodness, we're going to be looking at graphs that have 2 equation lines on it. So we're going to have to think about what those solutions might look like on those graphs, okay? Then we're going to be able to interpret ordered pairs in the solution, like in the context of the story. So we're going to be given an ordered pair on a grid that is labeled like miles, minutes, and we're going to have to interpret what that ordered pair means in the context of those different labels, okay? That's what we're working on for today. We have 2 goals for the end of today. First piece is this second one here is going to be addressed in our first activity, pocket full of change, or pocket full of change. Pocket full of change, okay? First thing I'm going to ask you, I have $2 in my pocket. What could be in my pocket? Kaylee.
You have $2 in quarters.
So $2 in quarters, so how many quarters would that be?
That would be 8 quarters.
8 quarters, good. 8 quarters, good. What else could I have in my pocket? Where's it?
200 pennies.
200 pennies, good. I like that was good, Diego. 200. Oh, that was Sawyer? Oh my goodness, that's awkward.
No, that was totally me. Yep. No, I'm playing.
Sorry, Diego. Out.
I'm playing. That wasn't me.
Okay, Avery said 2 $1 bills, okay? 2 $1 bills. Brenda, what else could I have in my pocket? 8 quarters, 200 pennies, two $1 bills, huh?
10 dimes.
10 dimes would be $1. So how many dimes? $2? So we have 10 dimes is $1. So if I have $2, how many dimes?
20.
20 dimes. Yes, Brando. 20 dimes. Kaylee B, you have another idea?
No, I was going to say it's
Oh, 20 dimes. Nice job. Oh, Diego, this is the one that I was thinking about that I didn't think anyone was going to say. The $2 bill. It's real. I should have brought one in today. I don't even know why I didn't.
Yeah. It's a real thing. I've seen that.
I used to get one every birthday from my grandma. She would give me a 10 and a 2. And so I have a stack of $2 bills in my room because they're not worth anything, but I think it's weird to spend. What else could I do? What if I said I have 4 quarters and I'm like doing a combination now? If I had 4 quarters, how many dimes would I have to have? 10? Okay. Let's think of one more combination. Okay, so, oh, nice job, Avery. What else could I have if I'm thinking about like a combination now?
40 nickels.
40 nickels, good. Nice job. 40 nickels. Okay. What if I had, oh, nice job. 4 quarters, 100 pennies. That was literally the one I was thinking about, David. 4 quarters and 100 pennies. Good. So basically, the point of this sort of piece here is 2 things. One, to get us thinking about the value of coins, because we're going to be talking about coins today. And I wanted to show you that, yes, we could do all $1 bills, all quarters, all pennies, all nickels, all dimes. Or we could do a combination of a couple different things, okay? Because today we're going to be looking at this friend, I can't remember what her name is, and she is attempting, she has some money in her pocket, and we're going to try to find out what she has exactly in her pocket, okay? So if we look at the next piece of this here, oh, I just moved that, didn't mean to do that. Okay, if we look at the next slide here, if you're in your pocket, I think it's the bottom of that first piece, okay? We're looking at Jada, okay? So Jada told Noah that she has $2 worth of quarters and dimes in her pocket and 17 coins all together. So what does she have in her pocket? It has to have, it meets two criteria. First, it does what? How many coins does she have in her pocket?
17.
17, and it adds up to how much money?
$2.
$2. So it has to meet both of those criteria. It has to add up to $2 and it has to have 17 coins, okay? She asks him to guess how many of each type of coin she has. So this is sort of the process that Noah is going to go through to figure out how many quarters and dimes she has. So now he's saying to himself, here is a table. He made a table that shows combinations of quarters and dimes that add up to $2. So first he's thinking, what are some combinations that can get me $2? Okay, so he said 0 quarters, I'd have 20 dimes. He filled in 4 quarters, but he didn't fill in how many dimes he'd need to get that total $2. And then there's 2 more that he didn't fill in. And then we have 1 more combination. I want you to take 2 minutes right now to fill in some combinations. First, these partially finished ones, and then give me 1 more combination that we could have that adds up to $2, okay? I want you to take 2 minutes right now, add questions in the chat, and then I'm going to ask question by question, so you don't need to put your answers in the chat quite yet. Because I'm going to go like question by question. If you want to get the first one ready in the chat, you can. You might need some paper to write out some math if you need a little bit, if you can't do the mental math, that's okay. Let's sit here for now. We'll be 6 feet and then we can take our masks off if you want. Okay, we're going to take another minute for ourselves. One more minute to fill out this table of quarters and dimes that add up to $2. And also, this is supposed to be not too bad. Difficulty-wise. So don't be like, oh, fish man I am. I mean, yes, be like, I'm brilliant because you are. But don't be like, this is all we're doing today. It's going to get harder. I always bring the heat, guys. Brenda, if you want to take your mask off, you can. Close the button if you want to, you can as well. I'm not saying you have to, I'm just saying we're distance enough where you can. And then we're just going to spend the rest of the class like this, so it's not a big deal. Okay, so we have a total $2. I have 4 quarters. How many dimes do I need to make up the rest of that money? Bridget?
10 dimes.
Very good, because very good, Avery, because 4 quarters is $1. And then, so you need another $1 in the other coin, which is dimes, so 10 of those dimes, good. If you have 0 dimes, how many quarters would you have, Kaylee B? Nice job, Kaylee B and Gina DeRemos. It would be 8, because 4 quarters make up $1. So 4 times 2 is going to be, no problem, Gina DeRemos. So $2 is going to be 8 total quarters. Nice job, I didn't trick you. Here comes the tricky one. I have 5 dimes. How many quarters? Avery is saying 6. Brando, what were you thinking?
6.
Brando was also thinking 6. Brando, can you tell me why you were thinking 6?
4 quarters is $1, and then 2 more quarters is 50 cents.
Yes.
$1.50.
Yes, so he's saying he has 50 cents already in dimes, right? So he needs $1.50 more, and if I'm looking for $1.50 in quarters, he said $1 would be 4, plus one more, 120, or what? $1 is 4, plus one more would be $1.25. One more would be $1.50. Yes, nice job. I don't know if you can see my hands or not, but yes, very good. Nice job, Brenda. Okay, last combination. What was the last combination that we can make of quarters and dimes that get me $2? Kaylee, what were you thinking? Did you have an idea for this one or no?
No, I'm just laughing.
Oh, you're just laughing? Okay. That's I like to call it my, well, it sounds like the mom from Bob's Burgers, and it's like a New York act. I don't have a New York, I just like it. The mom from Bob's Burgers is hilarious. Okay, so Avery's thinking 2 quarters and 15 dimes. What do we agree? Do we disagree with this combination? Brandon's giving me a thumbs up. How much would 2 quarters be representing? How much money?
50 cents.
50 cents.
And then 15 dimes is $1.50. So yeah, it would work.
Very good. So if you were to bring them together, nice job, Avery, on that one, and Brando and Bridget and Kaylee B as support on that one. It would be $2 total. Awesome job. So in order to figure out how many coins this girl has in her pocket, the first thing Noah did was to say, how many coins add up to $2? Because not that many coins, quarters and dimes, adds up to $2. So these are our combinations that we have here. Good. Now we're going to think about another aspect to this. Now we're going to think about the second piece of this. So we talked about totaling $202. Now, if we look at the next slide, slide number 9 in your packet, it's on the back of that first page. We have to look at a graph of the relationship between the number of quarters and the number of dimes when there are one second. So the only thing that's not going to work for that, Sawyer, is the nickel, because we're only dealing with quarters and dimes in our pocket. So we can't have any nickels for that one. But also 103 dimes is a lot. That's like $10. So I wouldn't think that one. Oh, does that make sense though? Because we're only dealing with, she only has in her pocket quarters and dimes. So we're not even going to say nickels. We're not going to talk about pennies. We're not going to talk about dollar bills. No. We're only talking about quarters and dimes. Okay. Nice job there on that, Sawyer. Thank you for reaching out. Now, okay, perfect. Okay. So now we're going to think about this idea of this graph that now represents the number of coins when we have that total 17 coins. Okay. So now if you're just looking, we just looked at with that table coins that added up to $2. Now we're going to be looking at coins that, or when I have in my pocket, 17 total coins. So if we look at this graph here, okay, if we look at this graph here, our y-axis is talking about the number of dimes that she has in her pocket. The x-axis is talking about the number of quarters. So when she has 17 dimes in her pocket, she has 0 quarters. When she has 14 quarters in her pocket, she has how many dimes? 3 dimes. Nice job, Alyssa Button. 3 dimes. So that's what this graph is talking about now. It's talking about combinations of coins that add up to 17 total coins. Okay? So let's answer some questions about this graph. So keeping in mind the labels on these axes here, what does the point A represent? So first, what's the coordinate for point A? X comma Y over comma up. So if I'm looking at point A, what's the coordinate for point A? I'm going to give another 10 seconds for people at home to write it in the chat. What is the coordinate for point A? You're right on the back there, Brenda. Nice job. What's the coordinate for point A? Making sure that if you are at home, use your finger to sort of trace it up. What's my coordinate, Bridget?
8,9.
Very good. Nice job, Sawyer. Nice catch there, I mean. Nice job, Jaden Ramos. Very good. Nice catch there, Sawyer. 8, comma 9. X over, comma Y, up. Up. And then over. Good. So if we're thinking about it in the context of the story now, this 8 is going to represent, we have 8 what? Quarters, yes. So A represents 8. Nice job there, Jaden Ramos. 8 quarters. And what is that 9 going to represent? 9, Kaylee B? 9. Yes, Kaylee B. It's going to represent when she has 8 quarters and 9 dimes. Does everyone see how we did that and why that is?
Yeah.
Okay, because we said that X value, X-axis is talking about quarters, Y is talking about dimes, 8 quarters, 9 dimes. Good. Now, my other question that we're going to look at, we're going to answer using this graph again, is, okay, for next question, no problem, Diego. How much money in dollars is the combination represented by point A? I want you to take 20 seconds right now to, on your paper or on your slide, tell me, how much money does point A represent with these labels of dimes and quarters? How much money? Let me know in the chat. What are we thinking? How much money? Nice job, Isabella. Woo! Good to hear from you, girlie. I love to hear your beautiful voice. And when I say your voice, I mean your fingers, your finger tapping. Because you're typing on the keyboard. I don't know. It didn't make sense, okay? I have,
It's okay.
many of my days have many comments like that. Okay, let's see. I appreciate it. Bridget is going to help me out here. So, what did you get first for a total amount of money?
$2.90.
$2.90. $2.90. Oh, that should be a dollar sign. Let me try that again. $2.90. So how did you find that total amount?
Well, I know that 8 quarters equals $2.
So $2.
10 dimes would equal another $1, so I just subtracted 10 from that.
Okay, so she said it's close to $1, so like $1, but then she said it was $3, right? And then because it was only 90 cents, it was you could subtract 0.1 from that to get $2.90. Good. Is there a different way that somebody did it? I like that idea of it's really close to 100 and then minus it. You could also just write out $2 plus 9 dimes is worth 90 cents. So $2 plus 0.9 gets me that same amount of $2.90. Both of those work. Nice job. I'm sort of assuming that this is probably the way that most people went, and that is okay. If you went this way with it, that works as well. Nice job, Jaden Ramos. That was this. Okay. So this next slide is where it's going to start to get a little bit more challenging. So I know that we've sort of been going through today, and I know some of you guys are probably like, Miss, like, what are we even doing? This is so easy. It's gonna get more challenging, and it's day one of like this mini unit inside of this new like subunit, okay? If it's still challenging, that is okay. And it's supposed to be a little bit challenging, okay? Let's take a look at the next piece of this, because now we're going to use some of this information. And actually, before we go, I want to think about it. Is this combination a combination? So the eight nickels, the 8 quarters and the 9 dimes. Is that a combination that she can have in her pocket?
No,
Why not?
because it doesn't equal $2, it equals $2.90.
And it has to be both, right? It has to be, she has to have what? Think back to like the story. It said that she had some coins in her pocket.
It has to have 17 coins.
She has to have 17 coins, and it needs to do what? Add up to $2, right? So it has to set, I hate using like these bigger words, but I'm going to introduce them. It has to satisfy both of the parts of the story, right? It has to be true for both parts of the story for her to have that in her pocket. This one, it's only true for one of those. Very good. Let's take a look at the next piece of this. Oh, let's see. Diego, why does Diego always leave when he goes to the bathroom? Last piece we're going to be talking about with this change piece, okay? So once again, this graph represents when you have 17 total coins, combinations when you have 17 coins in your pocket. Okay, okay, there we go. Okay, is it possible for Gina to have 4 quarters and 13 dimes in her pocket? So what is it, first of all, what does it need to have? Go ahead, Alyssa.
17 coins.
It has to be 17 coins. And it has to what?
Equal $2.
Equal $2. So I want you to look at this combination of 4 quarters and 17 dimes, and I want you to decide, does it satisfy both of these conditions here? Take a minute and a half right now to decide, does 4 quarters and 13 dimes satisfy this situation? Let me know in the chat, what are you thinking? Thirty more seconds, my friends. What do we think? Is this a combination of coins that she could have in her pockets? 10 more seconds, 18 more seconds. Oh, it's probably some attendance. Okay, here we go. Hello. Friends at home, nobody has an opinion? Is this a combination? Oh no! Is anybody out there? Anyone alive out there? Can anyone hear me? Jane says no. Bridget, what are you thinking?
I think no,
Why not?
because there is 17 coins altogether, but it's not equal to $2, it equals $2.30.
Ooh, you're doing so great today, Avery. Very good. Nice job. Gabby Kempany also said no. Very good. So does it equal $2? It doesn't, because $4 is $1, or 4 quarters is $1. 13 dimes is $1.30. And when you add them together, it's how much money? $2.30. So that is why it does not satisfy, and it's not going to be the number of coins she has in her pocket. So now what I want you to do, I want you to take for yourself, I want you to take 2 minutes right now to find, I want you to find the number of, the combination of coins, quarters and dimes that will equal $2 and make it so that you have 17 total coins. I want you to do some testing of points to figure out what is the combination, the magic combination. Okay? Go ahead, give it a shot. Once you get your answer, I'm really proud of you, Avery. I know I already said that, but I'm going to say it again. Once you get your answer, you can throw it in the chat. What's your combinations? Oh, you're really tired today. Oh, okay. That's okay, Avery. Ooh, Elizabeth already got it. Ah, scary. I'm going to fall on you.
Oh, it's nice to go to the bathroom.
Oh, yeah, go ahead. Fill out your pass. Fill out your pass, lady. Jaden Ramos, does it satisfy both of the pieces though? That it has to have 17 coins and be equal to $2. It has to be both of them. Take another look. You got this, Jaden. You're doing great. Another 38 seconds. Okay, here we go. My friends at home, Jaden Ramos put his answer in the chat. I need everybody else to put their answers in the chat. Okay, question. Brandon, did you get a combination? You did? What'd you get? 2 quarters and 15 dimes. Can I get a thumbs up or a yes in the chat if you agree with Brandon? What do we think? People at home, what are we thinking? Do we agree? Yes or no? Nice job, Jane Ramos. Jane Ramos is on. Kaylee B is going to help me out. And why did you agree with that? What did you think?
Well, because I remember from one of the examples, like the first one we did, Avery actually said 2 quarters and 15 dimes equals $2, so I remembered that.
Good. Okay, so we know that the 2 quarters, which is worth 50 cents, and then the 15 dimes, which is $1.50, adds up to $2. Very good. Good, so it satisfies that first piece of $2. And then what else? Did it also have to satisfy?
Having 17
Having 17
coins.
coins. And so to find the total number of coins, Brandon, what did you have to do? What was it?
What?
So to find the total number of coins that I have in my pocket, what did I have to do to those numbers? I have 2 quarters and 15 dimes. So how do I find the total number of coins I have? I do what with them? Add them together, right?
Yeah.
Because 2 quarters plus 15 dimes, that's 2 quarters, so 2 coins plus 15 coins. How many total coins do I have? 15 plus 2 is 17. Very good. So you want to make sure that both of these are written down in your box here because it says explain your reasoning. So we said 2 quarters, 15 times. And we have 2 sort of pieces to show for it. The 50 cents plus the $1.50 equals a total of $2. And the 2 quarters plus the 15 dimes is going to get me a total of 17 coins. Okay? Does that make sense? So when we're talking about these guys, when we're talking about these stories in the future, it's going to have to satisfy but make both of the statements true. So it's going to have to add up to $2 and have 17 coins. It's going to have to, it's really going to be like a total of 13 people and 2 more boys than girls, like something like that. So we're going to be looking at satisfying both of the criteria. Okay? And I'm going to use that word satisfy, but not like in the way of like satisfactory. It's like it makes it true.
It meets like both. I don't know. How to-
Exactly true. It's exactly true. Good job. Boom. Oh, it's a button coming back in for the win. Nice job. So I'm going to be using that word satisfy. I don't mean like that was satisfying because it was satisfying food, but I'm talking about math today, I guess. Yes, Snickers satisfies. Yes, Sawyer. That was what I was thinking about in my head. Snickers satisfies. Okay, I like it. Yeah, Sawyer. I love when you guys say things like that. It makes me so happy because then I can be silly and break the tension. Okay? Now, we're going to talk about the second activity here, where it's called making signs. Okay? And with making signs, we're going to look at slide number 12 first. It has this graph on it. And I want you to tell me right now, I want you to take 20 seconds to look at this graph and tell me, just looking at the graph, don't read the story, what do you notice about this graph? Anything. Anything at all. What do you notice about this graph? Let me know in the chat if you would like to share out your answers as well. Because this one is like one of those things that it could work for many things. Avery said it has 3 points on it. Good. Jane Ramos said it goes up. And I like the cap locks. Don't apologize for cap locks. Cap locks rocks. Bridget, what else do you notice?
But there's 2 lines.
There's 2 lines. Olivia says they intersect. What were you thinking, Alyssa Button?
They both start on the y-axis.
Good. They both start on the y-axis. And what did we call that if we think back to last unit? We call that the intersect. Good. Kaylee B, what are you thinking?
Neither of them went through the origin.
Neither of them went through the origin. Means they're not what?
They're not proportional.
They're not proportional. Why am I using that creepy like demon voice? I don't know. But because I'm really impressed by everything that I'm hearing. I'm hearing they're going up. They intersect. They hit the y-axis at different points. I love the cap locks. I love it. Brando, did you notice anything else that we haven't talked about yet? No, very good. Avery also said, I want to go back to what Avery said. Avery said that there were 3 points that fell on the lines. Good. Okay. So now we're going to use this graph and we're going to add some context to it, some meaning to it. okay? In like a real world situation type deal. So let's take a look at what the story behind this is, okay? We're talking about Claire and Andre. Claire and Andre are making signs for all the lockers as part of the decorations for the upcoming Spirit Week. So basically we're making signs, okay? Yesterday, Andre made 15 signs and Claire made 5 signs. So they're both coming in with, Andre's coming in with 15 signs done, Claire's coming in with 5 signs done. Today, they need to make more signs. Each person's progress today is shown on the coordinate plane. So, my question to you, number 1, which line represents Andre? The blue one or the black one? Brandon, what are you thinking? Oh, did you have your hand up? Oh, never mind, sorry. Alyssa Button, what were you thinking? Which one represents Andre? Which one represents, which one represents Andre?
The black line,
Why do you think that?
because it starts at 15 and then Y intercept.
Yes! It starts at the 15 on the y-axis. Yes, girl! So this black line represents Andre. Yes, Colleen. It's the brilliant for me. Try. Kaylee B now. I want you to think, which one of these lines is going to be Claire's then? Ooh, why do you think that? Prove it to me.
Because she came with 5 signs and the line starts at 5.
Yes, brilliant. Because this is Claire's. Because she hits this y-axis she comes in with, she starts with 5 signs already made. Good. So it'd probably be a good idea to label these 2 grids right here because we're going to be answering some questions on the next slide based on these graphs. And based on like Claire is the blue one and Andre is the black one. So let's take a look at these guys again. And we're going to answer some questions about these, okay? So we're going to say this one was Claire and Andre. Okay? Okay. So we're looking at different points that fall on this grid, okay? So if we look at point A, what it says, what that point says, if you were to look at it in the context of this story, A says that at 40 minutes, I have 25 signs completed. So that means when we're talking about time, which one of our axes is talking about time? Kaylee? Oh, you're stretching. Alyssa?
The egg.
The x-axis.
Yeah.
Yes. If we look, time is on our x-axis. So that means the number of signs completed is on our y-axis. Okay, so to get to that point A, we have to go over to what number? To get to point A, we're going to go over 40 and up to 25. Good. So who is that true for? Andre? Is it true for Claire? That if you, for Claire, on Claire's equation line, this blue one, if I go over to 40 and up to 25, is that true for her?
No. Wait.
Well, look at Claire's line. Does Claire's line go through the point 40, comma 25?
Oh, yeah.
Yes, so that's true for Claire, because if you go over to 40, up to 25, Claire's line is going to hit that point.
Yeah.
Now, if we look at that same point, does Andre's line go through that point as well?
Yes. Yeah.
Yes. So it's true for both of these friends here. Okay? Now the next piece of this is point B. So that's this guy right here. At 75 minutes, I have 42 and a half signs completed. So I have to go over to how many minutes?
75.
And then up
2.5.
42 and a half, which is point B. Is that a true statement for Claire? If you look at Claire's line,
Yeah.
does it go through that point? Yes. If you look at Andre's line, is that true for Andre?
No.
No, because at 40 minutes, how many signs does he have completed? Make a guesstimate? Or 70 minutes, I'm sorry, 75 minutes? He has about
35.
35-ish, yes. Very good, nice job. So we got that second one done. Now at 0, so point C, at 0 minutes, I have 15 signs completed. Is that true for Claire? No, because at 0 minutes, how many does Claire have done?
He has 5 done.
She only has 5 done, nice job. So that is false for Claire. What about, is that true for Andre?
Yes.
Yes, because his equation line, oh my gosh, it goes right through that point. Crazy. Now, last one. At 100 minutes, that means I'm going to go over how many? 100
60.
up 60. So that's going to be point D here. Is that true for Claire?
No.
Why?
Because her line doesn't go through the point. Yeah.
Good. It's false for Claire. What about for Andre?
It's also false.
It's also going to be false because why?
Because his line doesn't go through the point either.
Very, very good. Nice job. So when we're talking about this idea, this concept of solutions to an equation, for it to be a solution, the point has to fall on the line. So B is a solution for the blue line, but not for the black line. Point A is a solution to both of our equations because it falls on both of those lines. Okay, last question before we move forward. It's sort of unrelated, but I want to make a connection to last unit. Who is working faster here? I'm going to do a survey. Tell me in the chat. Who's going faster, Claire or Andre? C or A? Who's working faster?
Yeah, I think Claire.
Bridget? Brandon, what do you think? Who's working faster? Claire? Okay, two friends at school or at home, 3 friends at home are thinking Andre. Andre? Claire is Sawyer saying Claire. Oh my goodness, we're a close race right now. What else do we think? Isabella, Lily, what do we think? Okay, so how can we figure out who is going faster? Who's making more? Brandon? Yes.
Their lines can like, so is Claire, is it going up? No, it's going.
Steeper. It's a steeper line. Yes. We could also, oh my goodness, we could also calculate their speed by drawing in what? A slope what?
Triangle.
Triangle. A slope triangle. Yes, exactly. So if you were to come to Claire's or Andre's line,
You have to
find 2 spots where it crisscrosses perfectly.
Yeah.
This is a jump of 5 signs and a run of 10, 15 minutes. So every 15 minutes, he makes 5 signs. If we look at Claire's, every 20 minutes, he makes 10 signs.
So Claire's is working faster.
5 over 15, that is 1/3. 10 over 20 is 1/2. Boom! Which one's a bigger fraction? Claire's. The 1/2. Yes, totally unrelated, but I thought of that last period and we had a big discussion about it and it went really well. So just wanted to bring it up. Last little bit for today. Okay, it's just a summary. So we're talking about today I know I didn't use this word of solution all that much, because today we were really looking at in doing discovery. What do we notice about these graphs? Or is this a true statement based on these graphs? We're going to be introducing this term, using this term a lot, solution, moving forward. In a solution to, when you have two equations, a solution to those equations is a point that both equations have in common, or an intersection point. So if you're looking at these two equation lines, B and A, nice job, Jaden Ramos. I love that word. So, B and A, we're looking at lines B and A. Which of those points there is the solution to those equations? What are you thinking, Bridge?
Point K,
Why do you think that?
because it's the only point that intercepts
Very
both lines.
good. Very good. So if we're looking at these two equation lines, and we're looking, what's the solution to those two equations? We're gonna say K. Kaylee, what were you thinking?
I also said K because it's the point that's right in the middle of the graph, so they both go right through it. And that's where they meet directly.
It's where they meet directly, exactly, and it's right in the middle of the graph. Very good, nice job, Kaylee B. That was a very good point. So, point M,
Could you repeat that?
scared me. Yes, I can try, I can say that again. Oh my goodness. Oh, I just got all sweaty for a second. Whew. Okay, so we said point K is the solution for two reasons. One, because it's that intersection point, it's where these two equation lines meet, right? So they meet right here at point K. So that's going to be the solution to those two equations. Kaylee B said it's where they meet, right? It's where they crisscross. Okay?
Because they directly intersect.
And they directly intersect. I like that phrase. They directly intersect. I like it. I'm so proud of you. Nice job. So now, if we look at point U, what do we notice about point U?
It's not even on the line, either of the lines.
It's not on either of the lines. So that is
Off
not,
to the side.
it's all the way to the side.
It's also in the negative point.
It's in the negative point, right? It falls at like -2, -2. So if we're looking at an equation and we have a point, and we're looking at a graph and we have a point that doesn't fall on any of our lines, it's not a solution to any of those lines, huh, Matthias? Nice, awesome job today. Homework for this evening. Here's the dealio.
Do you have to do this?
Nope, you don't have to do the last one. We're gonna skip that last one because I didn't like the way it was like phrased in my book.
Like worded?
I did it.
Oh, well then awesome job for you, sir. Let me go through the homework for this evening, okay? For this evening, we have, I put on classroom 20 minutes of Alex time. The reason I put that 20 minutes of Alex time is because we have to have 60 minutes done total by the end of the week. So if you are already at like 50 minutes and you're gonna do 10 more tomorrow during CCR, I mean, I guess you're okay. But if you're only at, when you look in Alex, if you're only at 20 minutes for the week, I would do 20 minutes tonight. Okay? Because we have to have a total of 60 minutes done by Friday. Does that make sense? And if you, there's also going to be in there, it's going to say you have to have 5 topics mastered. So try to get all 5 of those mastered as well. But I think you can get 5 done in an hour.
I think I have 2 more topics to master.
Yes, Bridget. Okay, so you have the homework for this evening. You know what it is. You are going in and you are working on your Alex time. Tomorrow, we're doing a presentation on different pieces of Alex, cool things that we can do with it, and how we're going to use it in the future. So make sure you are in class for tomorrow because we're going to go through Alex in depth, okay? If anybody has questions for me about homework or anything like that, please let me know. Or questions about anything at all, really, send me an email or let me know in the chat, and I can help you out. Okay?